Okay, I'm going to work with you on factoring trinomials that have a leading coefficient other than 1. So some of you may have been taught different methods, bottoms up method, box method. I'm going to show you one that's called oftentimes the master product rule. You may have been taught this as well. So just like the box method, if you've seen that, what we're going to do when we have a leading coefficient, we're going to multiply that leading coefficient times the constant value. These need to be in standard form when we do this, but we are going to multiply 3 times 21, and 3 times 21 is 63. That is the number we are going to try to factor and to see which factors of 63 can result in 16. So I'm also going to show you another little trick. It involves a TI-83. You can use this on Desmos as well, but a lot of people have a hard time factoring. So what you can do in your y equals of your graphing calculator, type in y equals 63 divided by x. And what you're going to see when you look at the table, that's second calculate, is it's going to give you all of the values when you divide 63. And your list looks like this: 1 and 63, 2 and 31.5, 3 times 21, 4 times looks like 15.75, 5 times 12.6, 6 times 10 and a half, 7 times 9, and 8 times 7.875. And when these numbers pass one another, here's what I mean. 1 is lower than 63, 2 is lower, 3 is lower. When the numbers pass one another, stop looking. Otherwise, you're just going to see the mirror image of the ones you found. So I used my y equals 63 divided by x in order to find all the factors. Now, the factors that are not whole numbers are not factors we can use. So like 2 times 31, not usable, 31.5, 4 times 7, this, and this. So what we've done is we've narrowed down our usable factors, and those factors are only 63 and 1, 3 and 21, and 7 and 9. Now we need the factors to equal 16, like we talked about at the beginning. So what we're going to do is replace 16 with the equivalent of 16. I like to draw these boxes here. There's nothing that says you have to do this. I often call this the bookends. 3x squared and 21 just get brought down. And what I'm going to do is replace 16 with the equivalent of 16. The equivalent of 16 would be 9x and 7x. I could flip-flop those, but try to pay attention when you put these here. I can see that 3 and 9 are going to factor. I'm about to do some factoring by grouping. If you mismatch these, you will still get the correct answer, but you're going to probably work a little harder than you need to. But anyways, so I have chosen 9 and 16 because they meet both criteria. They both multiply to equal 63, and they also add to be 16. 16x technically, but we are now going to factor by grouping. So again, 7 plus 9 is 16. That's why I chose that. Now I'm going to factor by group. I group these two together. Notice I kept the plus sign out of here. That oftentimes keeps me from trying to turn it into multiplication instead of addition, which it will be. So I factor by group, and I see that 3x squared and 9x, well, they both are factorable. They both have factors of 3, and they both have an x. When I factor a 3x from 3x squared, all that's left is the x. When I factor a 3x from the 9x, all I have is the 3. Now I'm going to stop right here and just discuss something with you. When we factor the second one, we better see the x plus 3. If we do not see the x plus 3, we either did not factor completely, or we did not pick the right two numbers in the middle, or we misfactored. So pay attention. We want this thing to be x plus 3, otherwise we cannot combine like terms, and we'll talk about that in a second. So we see 7x and 21. Well, they both have factors of 7. I'm going to carry down this plus sign before I forget it. I factor out a 7 from 7x, and I can also factor a 7 from 21. And then when I do that, surprise, surprise, I factor a 7 from 7x and I get a 7. I factor a 7 from 21 and I get a 3. There's that x plus 3 we were talking about. Now, when we combine like terms is when you multiply, when you're multiplying two numbers by the same thing, when you're adding two numbers that are being multiplied by the same thing, you combine them and multiply one time. For instance, if I had 3x plus 7x, for instance, I put the 3 and the 7 together and call it 10, and then I just leave the x as it is. Because I have two numbers, 3 and 7, that are being multiplied by the same amount, and then this will be our result. We have the same thing essentially happening here. We have two numbers that are being multiplied times x plus 3. So what I'm going to do is combine those two numbers. Now in this case, those two numbers are not like terms, so all we can do is stack them side by side, 3x plus 7. And we multiply one time. Now let's look back over at the left. Did we call this 10x squared? No, we did not. We did not change the power because all we were doing was adding. Here, all we did was add. So we do not change the power. This is just x plus 3. So this is how we factor a trinomial that has a leading coefficient other than 1. This principle also works if the leading coefficient is 1, but it's a longer drawn out process, but it will work. This procedure always works if the trinomial is factorable. I've got one more example for you. Okay, I made a quick change on you because I had another plus sign, and I want to have one that has a negative or a subtraction sign in here. So I changed this one around a little bit. We're going to follow the same process though. We're going to start by multiplying our leading coefficient times our trail term. So 5 times 21, negative 21, is negative 105. That's my magic number. I like to refer to it as that. So what I'm going to do, I don't know the factors of 105 right off the top of my head, so I'm going to go 105 divided by x. What I'm essentially doing in my calculator is telling it to divide 105 by every number. And then I'm just going to reference the numbers from my calculator and see which one of those that work. I'm not going to write down the ones that are decimals because the ones that are decimals are not useful to us in factoring. So like 2 is 52.5. I'm not going to write that down, but 3 is 3 times 35. And remember, as I do these, I'm trying to get a combination of numbers that can give me 8. 3 and 35 are not that. The next one I look down, 4 is a decimal, 5 times 21. 5 times 21, closest we can get on that is 16. But doesn't work, so I keep looking. And then I see 7 and 15. Well, 7 and 15 can become positive 8. Because remember, this is negative 105, so that means one of the two numbers has to be negative. Now, big hint for you, if the middle number, like in this case, 8, is positive, the bigger number will be positive. So I would look at positive, 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 and the smaller number is going to be negative. So is it possible for negative 7 and positive 15 to become positive 8? It is. That is our solution right there. That is not our solution. That's the answer to the question, what are the factors of 105 that can become 8? There's no need in looking any further because we now have our answer. So what I'm going to do, again, I'm going to carry down my 5x squared. and I'm going to carry down my 21, and I'm going to change the 8x to a different version of 8x, and that version is, and again, think about what we want to do. I'm using the number 7 and 15. Which one of these makes more sense to go with the 5? Hopefully you're saying the 15 because we know that those are both factors of 5. Multiples of 5, excuse me. And then we put positive 15x and negative 7x. Now that we have these, we are going to factor by grouping. I want you to watch this little trick I do in the second part. I'm going to put the parentheses there, but remember this is addition, so squeeze that plus sign in there. I see too many students that try to that accidentally turn this back into a multiplication of numbers, but that's actually an addition, because remember it was addition of a negative number, so it's plus negative 7 essentially. So the factors of 5x squared and 15x is 5x, and this is going to leave me with x plus 3. And remember, the x plus 3 needs to match on my second term, and we will shortly see that it does. I can factor out a negative 7. Remember, anytime you factor out a negative number, you have sign changes. So the 21 does change to a positive 3, and it matches the other side. So just like on the last problem, what we're going to do is take the two leading coefficients. We will put those two together and multiply one time. And now we have factored trinomial with the leading coefficient other than 1.